Hey, we're going to be looking now at ocean versus ocean convergent boundaries and what their characteristics are. And so today we'll start with looking at the topography of it. And here's a good example of one. This is the Tonga Trench here. And it's a very deep trench. We can draw a line across it, and we're going to do altitude, clamp to seafloor, and then we're going to go, let's just go straight across there and say okay. And then we're going to say show elevation profile. And you can see a really nice deep trench here. It goes down about 7 kilometers or so at this random point that I picked here. And so that is one of the main features of the ocean versus ocean boundary is a deep ocean trench. Another feature is an island arc. And so let's turn that off, zoom out, and you can see on the west side of here, you have a chain of volcanic islands, but yes, there's islands here. So that's another feature of these is an island arc. And you should note that these are not symmetrical. So there's the boundary is right here. This side is very low. This side is much more elevated. And so there's nothing symmetrical at all about these types of boundaries. So let's look next at the earthquake situation there. So we'll go over here and let's select a new region and just select our Tonga Trench area here, and we'll zoom to that region. And what you can see is very typical of a subduction zone you have the trench here, and there's lots of shallow earthquakes there. And as you go on this side, you can see that they get deeper and deeper and deeper. And that indicates that this side is the overriding plate. This side is the subducting slab. And so this plate here, which is the Pacific plate, is subducting underneath this plate over here, which is the Australian plate, and it's causing lots of earthquakes on the way down. And we can look at that in 3D and load that up. And you can see this is the view from the top, and as we look down, you can see a very nice Wadati-Benioff zone. This is this zone of earthquakes that's dipping down inside the earth there. And then we can also look at the types of earthquakes that we have there. And you can see these range up to pretty big. This is a magnitude 8.2 earthquake and very deep, over 600 kilometers deep. So the deepest here being almost 700 kilometers deep, and the largest being a little bit over magnitude 8 earthquake. And I wouldn't be surprised if boundaries like this were able to have a magnitude 9 earthquake. It's just that we have not yet recorded such an earthquake. All right, so next we're going to look at the volcano situation. And so let's add in the volcanoes of the world. And you can see a whole bunch right along this boundary right here. And so these are very active, explosive volcanoes. Let's zoom in and see if there's any particularly good one. Oh, that's a pretty one right there. Look at this island. And you can see this is Tofua Island, and it has a great big crater there with a crater lake inside. And here's a little side volcano right there, kind of a cinder cone that's building up inside of that one. Right next to it is Cow Island, and that one also has that is a volcano right there. So we've got some really nice volcanoes that are on that side. And once again, this is due to water being expelled from the subducting slab that's going down and being added to the mantle wedge on top of that, if we look here. So water from this wet slab is going into this wedge of mantle here. It's causing melting, and that melt is rising up to the surface and causing the volcanoes such as this to erupt. And then the only other thing to mention is that there's no correlation with seafloor age. The Pacific plate in this area is probably pretty old. We can look at the seafloor age here. We can see, yes, it's some of the, well, kind of medium old here. Let's see, 90, 100 or so million years old. And we don't have real good data over in this area right here, but it's probably even older. And that's the basics of an ocean versus ocean convergent boundary.